Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog. This episode is brought to you by our friends at Rollbar. Check them out at rollbar.com/changelog. Move fast and fix things like we do here at changelog. Catch your errors before your users do with Rollbar. If you're not using Rollbar yet or you haven't tried it yet, they have a special offer for you. Go to rollbar.com/changelog. Sign up and integrate Rollbar to get $100 to donate to open source projects via Open Collective. Once again, rollbar.com/changelog.
Hi everyone, Tim Smith here, senior producer at changelog. We have a fantastic show for you today. KBall just got back from JSConf Hawai'i and had the chance to do a live show with William Martins, Sean Wang, Lynn Clark, and Till Schneiderfeit. KBall asked some tough questions about the future of JavaScript and web development. Enjoy.
All right, hello JSConf Hawai'i. Before we get started, I want to talk a little bit about how amazing this conference has been, right? I mean, he was just talking about Hawaii, but how about like the variety that we've seen on stage? We have seen Moana. We have seen natural hair. We have seen Tamagotchis. I mean, let's give it up for the organizers a little bit for putting this thing together, right? So before we begin, I'm KBall. I'm one of the hosts. I'm a regular on JS Party. If you want to find JS Party, go to any podcast app, search for JS Party, you'll find it. All right, so I am joined today with 4 amazing speakers. They spoke yesterday, but I'm going to introduce them anyway. William spoke about TC39, the future of JavaScript. Sean spoke about Babel and some amazing things you can do with that, with the language. I don't know if I even need to introduce you two, you're so famous. But we have Lynn and Till, who both spoke about WebAssembly. And what we're going to dig a little deeper on today is this idea of the future of JavaScript, of web development. Where is this going? You know, how can we take all of these talks that happen independently and sort of try to weave a picture together of where this is going in the future? So we'll just start. I prepared a few questions. If y'all get a burning need to ask questions, you can raise your hand and I'll probably call out to you. But we've got plenty, so don't stress. So I want to start actually talking about the JavaScript language itself. William introduced us to some of the proposals that are there for advancing the language. And I noticed that there were a lot of operators involved. You know, in the pattern matching, there was a new arrow operator. It wasn't the fat arrow we're used to with arrow functions. It was the thin arrow. With the piping, there was a pipeline operator. And I'm kind of wondering, I'm going to throw this to William first, but any of the panelists are welcome to answer. Are we going to run out of syntax and operators? Like, is there room for a Tamagotchi operator? Where are we going?
I think this is a good question for Till, right?
So I think there are sort of 2 different answers to this. One is, we can, in theory, invent an arbitrary amount of additional operators and make them work somehow. Just put 2 characters next to each other that currently would be invalid and say, this is a new operator. And thin arrow is actually an example where we could have done that. When we introduced the fat arrow, the committee was pretty close to also introducing a thin arrow variant that didn't capture this value. But otherwise would have operated exactly the same. And the reason this is not done was mental complexity budget. And that is really what a lot of this is about, that an operator has to carry its weight. It has to be specialized in a way that allows people to use it as an efficient mental abstraction instead of just some weird characters on the page that make things unreadable. And if we didn't keep that in mind, then the language would be more and more just sort of this weird stuff on the page that nobody can clock. And So yes, we will over time introduce new operators, but we have to be extremely careful about which ones and make sure that they are actually useful enough.
That leads into kind of a question about the process of deciding what goes into this language. We talked about TC39 and the stage 1 that was going on there, but maybe can one of the panelists spell out the stages that things go through as they advance in the JavaScript language?
Okay, I can try that one. Okay, we have like a 5-stage in total. Like that is the strong wall. It's like we have a conversation in the bar and we are kind of drunk and say, yeah, what if we do this in JavaScript? Let's try. Like, and you try to present this to the committee, and then if you find a champion and this proposal, it's try to solve a problem. Like, yeah, you should shape the problem first, and then if you have a champion for championing this, and the committee decides that this is like something that worth more investigation, so they goes to the stage 1. So then they try to do a little bit more research on that and shape, like if it's syntax, like shape the syntax and the semantics of this proposal, and then goes to the draft, which is the stage 2. So then they start to write the draft of the specification, and then sometimes they have some implementation bubble and send to the developers to try that out, and then after they find some consensus on syntax and semantics of the proposal, this proposal goes to stage 3, which is the time that like they wait for some implementation on the browsers, and I think like then you see this implementation come into the nightly version of Firefox or Chrome, Canary, and so on. And then after everything's done, and they find a consensus to send to stage 4, which is the last stage. And then they have a cohort, I think, in March, right? And then this goes to the next spec, which is in July.
Lynn, you talked about similar feature advancement happening in WebAssembly. Is the process there similar, or how does the WebAssembly working group deal with this?
There are a lot of similarities and a couple of differences. So for WebAssembly, you do have also 4 stages that look pretty similar. There is a difference in advancing between the stages, which is that with TC39, you need really full consensus that happens at a meeting. Individuals from different companies can object. Whereas with WebAssembly, it's more the different implementers. Really, it's what they do is technically they take a vote, and people can say, I strongly disagree, I disagree, I'm neutral, I agree, strong agree. In practice, really, as long as the engines as a whole all agree, things will advance. So there are some technical differences, but it really is fairly similar.
Nice. Digging into one of those proposals that William talked about, there's this concept of binary ASTs, and essentially having a much easier to parse version of JavaScript. What's that going to do to the demand for WebAssembly, where one of at least the initial value propositions was, hey, this stuff can be compiled so fast that we don't need to worry about that initial startup phase? So
I'd say that it's actually pretty useful to look at the different kinds of use cases that that inspired work on these two. So for WebAssembly, a lot of the use cases were around desktop applications and games, at least that first inspired it. We're seeing a lot of other use cases now. And what needed to happen there was actually, startup time is important, but that wasn't the critical thing there. It was execution, how fast the code is running, rather than how fast it starts up. It was really, at the time, about bringing new things to the web that weren't already on the web. Now we're seeing that you can actually speed up things that are on the web, like the parser that I mentioned that is used in Webpack and our dev tools. or the Gutenberg parser, which is 86 times faster. But that's really a different use case than taking something like Facebook or Gmail and trying to make it start up faster. Binary AST is really specifically targeted at the problem of startup cost. And so with binary AST, we take this process that's really complicated and manual today, where you have to do all of these things to improve your startup times, like code splitting, and we automate a lot of that to make it so that you don't have to think so much about how to design your system to optimize for startup cost. You can just automate this process of getting a quick startup.
Yeah, just to put a bit more on top of that, like they are trying to, it's different problems. Like for like binary AST is something that targets the cold start of a JavaScript application. So it tries to make the compiling phase start faster, and WebAssembly is more about like runtime. So how fast your, how performant your code could be. So it's different kind of things, and they are. I think, as far as I know, like the community is not even sure if binary AST is something that needs to proceed, because, for example, V8 has a different way to parse the JavaScript. Like they have like they parse the JavaScript in a streamlined way. So and the POC they did so far it was only in SpiderMonkey. So they need to try to assess this, if this solution is even true. It's a performance win for the other browser vendors as well.
We are in Firefox, we're working on proving this out, and I think it is right for other vendors to say, well, show us the numbers before we go and duplicate the effort here. And the good thing is binary AST is a format where this, or is a proposal where this is possible. If we were shipping a language feature and then at some point said, no, we changed our mind and stopped shipping it, we would break code that depends on it. That's not the case with binary AST. It's really much like a minification step where nobody would only ship binary AST, at least for the foreseeable future. So if we at some point stop sending the header saying we understand binary AST, then we'll just instead get a JS file and nothing breaks. So that's good. And I do want to say something more about the motivation here. I think it's really important to look at this holistically. We want the web to be a platform where you can ship or deploy applications of all sizes to. And to make that work, we need to pull all the levers that we have access to. We can't just say, well, this seems kind of good enough, so let's not continue working in this direction. We need to do what we can for startup performance in all kinds of ways. We need to optimize runtime performance using the right language for the job, for the individual modules. And going forward, we'll eventually also want to look at similar things for the other parts of the platform, like HTML and CSS. And stopping at some point because we feel like this is fast enough for what people are doing now is selling the platform short.
This episode is brought to you by Gauge. Gauge is a free and open source test automation tool by ThoughtWorks with a goal of taking the pain out of test automation for acceptance tests. To help with this, Gauge supports specifications in Markdown, which are easy to read and easy to write. Reusable specifications to simplify your code, which makes refactoring easier, and less code means less time maintaining your code. And finally, integration. Use Gauge with your favorite tools and IDEs in the ecosystem of your choice, like Selenium and Sahi Pro, CI and CD tools like GoCD, Jenkins, Travis, and IDE support for Visual Studio, VS Code, IntelliJ, and more. Head to gauge.org/JSParty to learn more and give it a try. Once again, gauge.org/JSParty.
So in Sean's talk, you talked a lot about compile time optimizations. And I think this is something that clearly lends itself well in the WebAssembly world. What you were talking about with treating binary ASTs as essentially a minification or compile step. Where do you all feel we are in the sort of build systems around web development? You know, it feels like we've come a long way in the last few years, but does that mean that we're at about as good as it's going to get, or we are at step 1 of 10, or how far is this stuff going to go?
Wow, it's a very broad question. I'm far from an authority on this, but I think we're definitely at the beginning of build system innovation. In fact, a lot of these pieces were cobbled together and invented separately, and that's why people complain that there's no integrated end-to-end thing from npm install to Webpack to Babel, and having conflicts between all these different parts of the system make onboarding to web development difficult. I think there is some struggle against having such a complicated build system is against the original spirit of the web. You used to be able to just drop some JS onto HTML, and that's true. But at the same time, the way we use the web has also changed a lot, and so our tools should evolve accordingly. There should be more innovation on this. I mean, as much as I talk about compiling to JavaScript, but I think that obviously there's a huge case for compiling to WebAssembly.
Well, I think that, as you point out, the use cases that we're doing web development for have changed. And I think in your talk yesterday on WebAssembly, you talked about taking this concept of the web platform and expanding it beyond what we traditionally think of as the web. How far do you think that goes? Is eventually every type of development using the web development model and platform?
So in the talk yesterday, I made this sort of offhand joke about stealing your Bitcoin wallet, which of course is based on real-world events. And it's no joke. It's something that has actually happened. An application that you trust, where you rightfully trust the author of that application, still going behind your back and stealing your money, literally. Well, almost. It's blockchain. And this problem won't go away without us doing anything about it. And the way I see it, we can do something about it in 2 different ways. Either by locking everything down through orthography, going through app stores and letting the Apples of this world dictate what you can and cannot consume in terms of applications and media, or by going away from something that is otherwise incredibly helpful and increases the stability of applications and the productivity of developers, and that is code reuse through platforms like NPM. Or for Rust, we have Crates.io, which is very similar. And it's not scalable to try to review the entire code there for the hundreds of thousands of packages published there all the time. And we see that it's not scalable because nobody is doing it, nobody could possibly do it. And so we can give up on this code reuse, or we can say, well, let's work on things such that you don't have to trust all of this code. And to do that, we need proper sandboxing. We need to be able to say, as long as the application can only run in this directory, say, I don't actually care about whether it tries to steal my Bitcoin wallet, because it can't. I don't need to trust it in this regard. And for that, we need to bring a sandboxing model that is essentially similar to what the web provides to development outside the web in a way that still allows these applications to provide the value you want from them. And we're working on that.
When I was tweeting about your talk, I had someone who does native development respond and say, hey, do I really want my applications running in a browser? Isn't that going to be a little heavyweight? Isn't that going to slow everything down? And will that give me the access that I need? How do we address those concerns from folks who are used to being able to essentially access everything and run at a bare metal level?
So that I'm glad you mentioned the access everything. He mentioned me in that tweet as well. And this idea of a developer accessing anything on your system, that is great for the developer. It's really not great for the user. As Till was just talking about, it opens you up to so many different security vulnerabilities. So it's not just the web that has locked down on these things. You're actually seeing the operating system start to lock down on these things as well. Apple is actually starting to lock down on what their application developers can do. And I think that as developers see better systems for providing this kind of capabilities, but with a security around them, they'll start to accept it too, because it protects them. If they're reusing code from other people, it protects their applications from the kinds of exploits that they could potentially be vulnerable to, which I think most above-board developers are in favor of not putting their user systems at risk.
There's also actually a kind of funny part to this. When I looked at this Twitter conversation yesterday, I then looked at the timeline of this person who had posed these questions, and just a few days ago, they had compared iTunes and Apple Music and complained about how badly it works, and had compared it to Spotify and said, this is how an application should be done. It runs smoothly and is really well done. And at the same time, they complained about how all these web apps need an entire browser around them. Well, Spotify turns out to be an Electron app that brings its own browser with it. So turns out the web platform actually is maybe further ahead than they realize.
Awesome. So coming back a little bit to the languages that we're using to build this out, Lynn, you highlighted the need for easy and fast data exchange. Mm-hmm. And we saw yesterday some discussion of TypeScript, and I know there's a lot of type discussion in the JavaScript community right now. We also, one of the things that WebAssembly gives us is the ability to use languages like Rust and other things that have these high-level guarantees. When we're talking back and forth between these different environments, is there a mechanism within WebAssembly for translating those type guarantees?
Currently, that is up to tooling. And the Rust to WebAssembly toolchain that we are working on actually produces TypeScript definition files for the WebAssembly modules so that you can work with them in a strongly typed way. And you have to. You have to pass in the right types, and you have some kind of layer that converts what the WebAssembly module produces into something that you as a JavaScript developer can consume. And currently, all you have to interact with the WebAssembly module are numbers. Ints and floats are all that boundary can understand. Going forward, that'll change. Lynn talked about the garbage collection proposal for WebAssembly. And I'm actually the TC39 champion for the accompanying typed objects proposal, where we will have strongly typed JavaScript objects, where you don't only have the type of the object itself, but all the fields on that object are strongly typed and in a fixed location in memory so that they can be efficiently accessed both in WebAssembly and in JavaScript. But you will still want to have TypeScript definition files to see what that structure is and to have your editor give you hints about how to interact with that object. So that won't go away, and I actually think TypeScript definition files are the right way to approach that.
There's some, so I'm not too clear about this, but there's some discussion about the soundness of a type system. And I'm told that TypeScript it's not sound by default. And that could be a hurdle. I don't fully, is that something that y'all consider in terms of your discussions?
So the parts of the type system that we need for this are about the most trivial, basic ones. And that part is sound. There's actually
a subset of TypeScript.
Yes, it's absolutely a small, tiny
That's
subset.
That's what I've been thinking. Yeah.
There is something interesting for the TypeScript team to consider going forward. Once we add garbage collection support to WebAssembly, they could actually go and compile parts of your TypeScript to WebAssembly to make it run fast, But because the type system is unsound, and because even without that, it doesn't make sense to compile all code to WebAssembly instead of JavaScript, they could do it on a per function level. And if all engines have these fast calls that Lynn talked about yesterday and actually published a blog post about a few months ago, then it sort of doesn't matter which part of the system a function is implemented in. And the TypeScript compiler could really very fine-grained decide
Back and forth.
WebAssembly is good for this, JavaScript is good for this, let's optimize all the things.
I want to mention that there are two experiments done on JavaScript to compile into WebAssembly. One is WALT, W-A-L-T, which is kind of, you write a JavaScript-ish language that compiles down to WebAssembly. And there is another one called AssemblyScript, which is a subset of TypeScript that compiles down to WebAssembly. So yeah, I'm interested in see how they do this and how this can work out. Like maybe this could be a good starting point for writing JavaScript and see how this goes like back and forth from WebAssembly.
This episode of JS Party is brought to you by onemonth.com, one of the best places to learn how to code in just 1 month. Their courses have helped over 60,000 students go from knowing zero about coding to building programs in languages like JavaScript, Python, and Ruby. Onemonth.com graduates have gone on to get jobs at awesome startups like Airbnb, Instagram, and Spotify. Their courses are easy to follow with step-by-step video tutorials, instructor-led with weekly assignments reviewed by your instructor, and results-driven, with each student graduating the course with a portfolio of projects to show prospective employers, as well as a certificate of completion. If you're interested in taking your career to the next level, head to onemonth.com/JSParty and get 10% off any coding course. Once again, that's onemonth.com/JSParty to get 10% off any coding course. A big thank you to onemonth.com for supporting JS Party and online education.
All of this discussion about the manifold possibilities here reminded me of an ongoing conversation that folks are having about how we preserve the on-ramps to web development. It used to be that you just get started, you do a little bit of HTML, you can do your CSS and JavaScript right there, and you're already in, and it's straightforward and easy. And now we're getting into this polyglot language world, we're getting into complex build chains, we're getting into complex frameworks. Lynn, I know you do a lot of thinking about how to explain code concepts to people. I know that this is a surprise question because it just came up now. I didn't prep you on this, but do you have thoughts on how we keep making this accessible to folks?
That is a question that has come up a number of times because people are worried that when you introduce something like WebAssembly, does everyone then have to learn WebAssembly in order to be a web developer? And I think that the answer is no. I think that we can actually, all of the web developers can benefit from WebAssembly without ever having to learn it. If we have people like the React core developers re-implementing core parts of React, then people who are using it won't actually have to know anything about WebAssembly. They'll just see that the DOM diffing algorithm is going faster because the APIs that are on top of it will stay the same. And so I think that we can provide kind of this ladder, basically add another few rungs to the ladder that you don't actually need to climb. If you want to, you can climb those extra rungs and learn how to do WebAssembly development, but that you don't need to have the same level of proficiency that you do today and actually benefit from WebAssembly without having to learn it.
Yeah, I have thoughts. I mean, I agree. I think as we this industry is still super young. You don't, and as we professionalize and grow deeper, the learning curve is going to steepen. That's not an argument to stop development, and I think it's an argument for more people at every level, particularly intermediate, to produce content, to teach each other. I'm a big proponent of learning in public. Whatever you just learned, you are the world's most recent expert at, even though you may not have like 100% of the knowledge, or you may be incomplete and missing out some of the history of something. But you are best placed to explain to other beginners as well, because you have the beginner's mind, and that's something that experts don't. So I think that we should have more of that.
Awesome. I think we're getting close to where we're going to have to wrap up for the next speakers to come in, but I want to go around potentially to each of our panelists and ask you for a quick hit. What is one of the things that you are most excited about coming in the future of web development? And that can be JavaScript specific, that can be WebAssembly specific, that can be kind of global big picture of where the platform is going, whatever layer you want to hit it at, and in whatever order, because once again, I didn't prep you on this, sorry, throwing you a few curveballs. But what is something that gets you really excited about the future of web development? Because, from where I'm sitting, we're where it's at. Like, this is amazing. The stuff going on in this industry is phenomenal. And, this is an exciting time to be alive.
I personally am very excited about how far the web as a platform is going out of just for the web. For example, now you can create a PWA and install it on your Windows machine. So I'm very excited about that, because as a web developer, I'd like to do something more than just websites. So yeah, I'm pretty excited about it.
So I do a lot of, I spend a lot of my time in the React world ecosystem, I guess. So concurrent React is kind of the next thing that's being released by the React team, and it seems to be you think that we're kind of done with rendering lists of items on a page, but there's so many nuances and ways to declaratively make declare user interfaces better, I'm very much looking forward to the release of that over the next year.
I think that there are a bunch of things that I'm excited about. I talked about a bunch of them in the talk yesterday, but I think the thing I'm most excited for is WebAssembly's integration with the garbage collector in the browser, because I think that opens the door to so many different use cases where we use JavaScript and WebAssembly together, and where we use WebAssembly for the parts of an app that it really makes sense for, and speed up a whole bunch of these apps.
I'm excited about tearing down barriers between the web and all other platforms in both directions. So currently, if you want to have, or in the past, really, has sort of changed now. In the past, if you wanted to have an application available on desktop systems and Android and iOS and also the web, you built one portable application core for all these other platforms, and then individual user interfaces for all of them, and then you built the web version, completely independent from all the rest. Or you had to choose to not have that or not have the other ones. And we are changing that, where the web platform can be one of the others, where you have a portable core and you build a web-specific user interface using web technologies. That's the one direction. The other direction is bringing WebAssembly to other use cases in similar ways to how Node brought JavaScript to other use cases, and to the degree that web developers get more comfortable with using WebAssembly, and not all of them have to, of course, but those that do, we open new worlds for them. We open the ability to go into tiny niches where JavaScript would not be the right language, and apply their abilities there, and really blurring the lines between these very different platforms. That's what I'm really excited about.
All right, so as we wrap up, I want to get a hand for all of our panelists here. They're pretty amazing, yeah? I don't know how I got so lucky to get to pick the brains of these types of folks, but it's a pretty amazing thing. And if you like hearing from folks like this every week, take out your phone right now, look up JS Party. You can listen on the web if you really don't want to subscribe. You can listen wherever you want. And we bring content from conferences. We have regular guests. We've had, folks like John Rezick on the show. We've had folks, just incredible stuff. And, I listen to every episode, not just because I'm on the show. A lot of times I'm not on the show and I'm like, all right, I got to hear what they said. That's amazing. So check it out. Thank you all for coming. Thank you.
All right, thank you for tuning in to JS Party this week. Tune in live on Thursdays at 1 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. And do us a favor, share this show with a friend, rate us on Apple Podcast, go into Overcast and favorite it. And thank you to Fastly, our bandwidth partner. Head to fastly.com to learn more. And we move fast to fix things around here at Changelog because of Rollbar. Check them out at rollbar.com. We're hosted on Linode Cloud servers. Head to linode.com/changelog. Check them out and support this show. Our music is produced by Breakmaster Cylinder. And you can find more shows just like this at changelog.com. Thanks for tuning in. We'll see you next week.
Practical AI is a show hosted by Daniel Whiteneck and Chris Benson about making artificial intelligence practical, productive, and accessible to everyone. You'll hear interviews with AI influencers and practitioners, and they'll keep you up to date with the latest news and learning resources so you can cut through all the hype.
As you were at the Thanksgiving table with your friends and family, were you talking about the fear of AI?
Well, I wasn't at the Thanksgiving table because my wife has forbidden me from doing so. It's off limits for me, lest I drive her insane because I never stop.
New episodes of Practical AI premiere every Monday. Find the show at changelog.com/practicalai or wherever you listen to podcasts.